When determining the feeder demand load for a 6 kilowatt cooktop, the correct approach is to use the nameplate rating. The nameplate rating represents the maximum power the cooktop is designed to draw under normal operating conditions. Using column B, which is 3.5 to 8.75 kilowatts rating, or column C, which is 8 kilowatts, from unspecified tables may not accurately reflect the actual load requirements of the specific cooktop. The National Electrical Code, or NEC, provides guidelines for calculating feeder demand loads, and for cooktops, the nameplate rating is generally the starting point. It is essential to consult the specific requirements and tables within the NEC that pertain to cooking appliances to ensure compliance and safety. The NEC provides exceptions and allowances for demand factors based on the number and types of appliances, but without specific details. The nameplate rating is the most accurate and straightforward method. Considering the NEC, let's delve into how to properly calculate feeder demand loads. Firstly, you have to identify all the loads connected to the feeder. This involves determining the power consumption, typically in watts or kilowatts, of each device or appliance. These values are usually found on the nameplate of the equipment. Secondly, after identifying all the loads, determine if any demand factors apply. Demand factors are multipliers that reduce the calculated load based on the likelihood that all devices will not operate at their maximum power simultaneously. The NEC provides tables, such as Table 220.53, that specify demand factors for various types of loads, like ranges, dryers, and heating equipment. These factors account for diversity in usage. Thirdly, apply the appropriate demand factors to the respective loads. For example, if a feeder supplies multiple ranges, you might use a demand factor of less than 100%. This recognizes that not all ranges will be used at their maximum rating at the same time. Fourthly, sum the results obtained after applying the demand factors. This gives you the total demand load for the feeder. This is the amount of power the feeder must be capable of supplying. Fifthly, ensure that the feeder conductors are sized appropriately to carry the calculated demand load. The NEC provides tables, such as Table 310.16, that specify the ampacity, or current carrying capacity, of conductors based on their size, insulation type, and installation conditions. Choose conductors with an ampacity equal to or greater than the calculated demand load. Sixthly, verify the overcurrent protection for the feeder. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the conductors from overloads and short circuits. The size of the overcurrent protection device should be selected to protect the conductors in accordance with NEC requirements. It should not exceed the ampacity of the conductors. Seventhly, consider any voltage drop in the feeder. Voltage drop occurs when the voltage at the load end of the feeder is less than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a certain percentage, typically 3% for feeders and 5% overall. Calculate the voltage drop and increase the conductor size if necessary to meet the voltage drop requirements. Eighthly, account for any future expansion or changes in load. It's prudent to design the feeder with some extra capacity to accommodate future increases in load. This avoids the need to upgrade the feeder if new equipment is added. A common practice is to add a safety margin of 25% to the calculated demand load when sizing the feeder conductors and overcurrent protection. Ninthly, document all calculations and assumptions. Keep a record of all the load calculations, demand factors, conductor sizes, overcurrent protection ratings, and voltage drop calculations. This documentation is essential for future reference and for ensuring compliance with electrical codes. Tenthly, consult with a qualified electrical engineer or electrician. If you're not experienced in electrical calculations or if you have any questions or concerns, it's best to seek the advice of a qualified professional. They can help you ensure that the feeder is properly sized and installed in accordance with all applicable codes and regulations. In addition to these steps, there are other considerations to keep in mind when calculating feeder demand loads. For example, the type of load can affect the demand factor. Continuous loads, such as lighting and HVAC equipment, typically have a demand factor of 100%, meaning they are assumed to operate at the maximum power for extended periods. Non-continuous loads, such as appliances and motors, may have low demand factors. The NEC also provides specific rules for calculating the demand load for certain types of equipment, such as electric vehicle charging stations and renewable energy systems. These rules may differ from the general guidelines described above. Furthermore, the location of the feeder can also affect the calculations. Feeders that supply multiple buildings or structures may have different demand factors than feeders that supply a single building. The NEC provides specific rules for calculating the demand load for feeders that supply multiple buildings. It's also important to consider the ambient temperature when sizing feeder conductors. The ampacity of conductors decreases as the ambient temperature increases. If the feeder is located in a hot environment, you may need to increase the conductor size to compensate for the dirting. Another factor to consider is the presence of harmonics in the electrical system. Harmonics are distortions in the voltage and current waveforms that can be caused by certain types of electronic equipment. Harmonics can increase the heating of conductors and transformers and can also cause other problems. If harmonics are present, you may need to use larger conductors or install harmonic filters. Finally, it's important to stay up to date on the latest version of the NEC. The NEC is updated every 3 years, and new requirements and changes are constantly being added. Make sure you are using the latest version of the NEC when performing electrical calculations. In summary, calculating feeder demand loads is a critical aspect of electrical design. By following the steps and considerations outlined above, you can ensure that the feeder is properly sized and installed to meet the needs of the connected loads while maintaining safety and compliance with electrical codes. Remember to always consult the NEC and seek the advice of a qualified electrical professional when in doubt.